Okay, welcome here. My name is Adarsh Patil. Welcome to the Learn Logic channel, where we will be discussing the most basic chapters from physics, chemistry, maths of 11th and 12th standard. Let's move towards the today's content of the video. First point, we'll discuss the definition of atom. In the second point, we'll discuss the definition of element. Third point would be the definition of a molecule, and in the last point we'll compare the atom, element and molecule based on certain parameters. Moving towards the definition of atom. Atom is the basic building block of matter. It is the smallest unit of an element that retains the chemical properties of that element. Take an eye on this statement. It is the smallest unit of an element that retains the chemical properties of that element. Atom consists of a nucleus made of protons and neutrons surrounded by electrons that orbit the nucleus. You can see in the video, in the yellow region, you can see nucleus that is having protons and neutrons embedded in it, and around that nucleus electron orbits are there, where the point particles like electrons are shown, which are revolving around the nucleus. Let's move towards next slide. Here in the upper figure, you can see the size variation of particles or constituents of an atom. Let's discuss the size variation in terms of their diameters. First, proton diameter. The diameter of proton is in the order of femtometers. It is typically considered to be around 0.84 femtometers. Note here, 1 femtometer equals to 1 into 10 raised to minus 15 meters. Second, electron diameter. Electrons are often treated as point particles, meaning they have no measurable size or volume in classical terms. Therefore, their diameter is not applicable in conventional sense. If we try to compare the sizes of electron and proton, then we get to know that one size of one proton, that is diameter of one proton, is equal to 1000 times the diameter of one electron. Third, neutron diameter. Similar to protons, the diameter of neutron is also in the order of femtometers. It is approximately 0.88 femtometers. Okay, here you can see the small change in the size of neutron. Fourth, nucleus diameter. Diameter of nucleus is on the order of femtometers as well. It can vary depending on element and isotopes, but it's typically within the range of 1 to 10 femtometers. And the last, the first electron orbit, also known as Bohr radius, is a fundamental constant in atomic physics. It is approximately 0.529 angstroms. Okay, that is 0.053 nanometers. Note here, 1 angstrom equals to 1 into 10 raised to minus 10 meters. Definition of element. An element is a type of substance that consists of only one kind of atom. Elements cannot be broken down into simpler substances by ordinary chemical means. They are represented by unique symbols such as H for hydrogen or O for oxygen on the periodic table. In the left hand side figure, you can see the 3D view of an element or an atom. Third point of this video, definition of molecule. A molecule is a group of two or more atoms chemically binded together. These atoms can be of same element or of different element. Molecules can be simple, like oxygen molecule, that is O2, which consists of two oxygen atoms, or complex, like water, that is H2O, which consists of two hydrogen and one oxygen atom. Let's discuss the sizes of molecules. Molecules can vary significantly in size depending on number and types of atoms they contain. Simply, molecules like oxygen, that is O2, or nitrogen N2, have sizes in the range of few angstroms, that is 1 into 10 raised to minus 10 meters, while larger and more complex molecules such as proteins or DNAs can be much larger, ranging from nanometers to micrometers. You can see the visual size of a molecule that can vary. Also note that 1 micrometer equals to 1 into 10 raised to minus 6 meters. Let's move towards the differences. Based on definition, atom is the basic unit of matter. A substance with one type of atom is known as element. A group of two or more atoms chemically bonded together is known as molecule. Composition: atom has composed of protons, neutrons and electrons. Element is composed of only one type of atom. Molecules are composed of two or more atoms of same or different elements. Depending on size, atoms are sized from 0.1 to 0.5 nanometers. That is overall the size of outer nuclear electron periphery. Element has the size ranging from about 0.1 to 0.5 nanometers, somewhat closely related to the atom. The sizes of molecule are ranging from 1 angstrom to micrometers, as seen in the previous slide. Continued the differences. Fourth point would be representation, how the representation is done for atom, element and molecule. Atoms are represented by chemical symbols. For example, hydrogen, for representing hydrogen, H is a symbol which is used. Similarly, elements are also represented by chemical symbols. Here also H is a chemical symbol for hydrogen and O is chemical symbol for oxygen. Molecules are made of two or more atoms of same element or different elements. That means for oxygen the chemical formula would be O2, for water chemical formula would be H2O, nitrogen N2, and varies upon the rest. Okay, examples of particulars. Then atoms. Examples of atom include hydrogen atom, oxygen atom. Similarly, element also similar, has a hydrogen element, oxygen element, and in molecule, water, that is H2O, carbon dioxide, CO2, nitrogen N2, then benzene C6H6. Okay, similar there. That kind of things are there. Then fundamental role in the what they perform. Atom are fundamental unit of an element. Element are fundamental unit of a matter with specific properties. Molecule are a fundamental unit of a chemical compound. Characteristics: atom cannot be broken down into further without losing identity. Element contains atom with the same number of protons. Molecule can be simple, like of same elements like O2, or complex like H2O, having different elements. And the last point would be the behavior, how the particulars are behaving. Atom participates in chemical reactions to form compounds. Element represents a pure substance with distinct properties, and molecules exhibit unique properties based on its constituent atoms. Here we come to end. Thank you. Jai Hind. Stay tuned for the further upcoming videos of physics, chemistry and maths. This series is continued for chemistry. We'll continue for the further classes. Thank you.